Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about Roman Space Telescope. So let's dive right into it. Now, what exactly we are talking about? We are talking about Hubble's replacement. Now, you may think, what about JWST? Now, James Webb Space Telescope is not Hubble's replacement because it's looking at very deep infrared. It cannot even do an optical photos. This is optical first, little bit of infrared, little bit of ultraviolet, but that's its main point. JWST is like going deep in infrared. So NASA got a telescope mirror as a donation. Now we're like, wait a minute, what? Now this sort of thing happens, it's kind of common. Now many times if you have followed a development of Hubble, you must have heard like it's just a spy satellite inverted. Rather than looking at Earth, it's looking outside. Yeah, that is true. And now I know why people say that is simply because the whole setup, the whole quote unquote architecture is taken from a spy satellite. Now NRO, National Reconnaissance Office, they are responsible for making spy satellites and taking care of the payload, paperwork, data. So they do not leak anything. They cannot even share the data with NASA. So they're like, okay, we build something. Now here's the deal. Whenever you're talking about spy satellite, something of this caliber, you can understand that puppy will be expensive, and they will be placed in bulk order, like 5 satellites, 10 satellites, or things of that nature. So there was a very good chance they would have, of course, deployed 5 or 6 of them. But by the time they had like 7th or 8th were under construction, they were like, realized that it's no longer up to date. Meaning now they have better instruments. They have to basically retool the design. So they had a scenario where they had like almost completely built spy satellites that were like useless, but it had good glass. So they were like, how about we donate it to NASA? We'll strip everything out of it, just the glass. Just the glass. Whole satellite bus will be stripped so it cannot leak anything. And there will be one condition on NASA, that thou shall not look at Earth, because once you'll do that, it will expose how well basically NRO can actually spy on other countries. That's like, nope. So that's the rule. NRO gave them 3 systems, and again 2 are very well built, almost complete. One of them is like, I'm not sure like what is the status of that, but the whole project, this whole Hubble's replacement project, was retooled to adapt this goddamn mirror. That's it. Like the mirror was there, they're like, okay, now replan the mission around it. Now Nancy Grant Roman, basically this lady, why her name is being used? Well, very simple reason. She is the chief of astronomy, meaning was as in back in the old days, NASA was created in a hurry. Basically, it was just go to the moon. It was a very like you are built together, get your ass to the moon. That's it, done, nothing else. So what after that? Now back in that days, people were familiar with the capability of space, and they thought of it as a telecommunication backbone, meaning we'll have communication, TVs. Those are awesome things, but nobody was thinking as a research tool. No one was thinking it was like astronomy kind of thing. Now what she did is like quite amazing. She actually sat down engineers. It's like, bro, sit down, tell me what you can actually build in the constraints of reality. It's like, because again, I would want like, I want like 10-meter diameter lens, and it's like, of course you have to calm down. You have to be like, okay, what can we really do? So she had a rough pilot diagram. It's like, we can do this sort of thing. Then she went to university, and she was the first of trying to take this sort of approach. And she was like, what would you like to observe? How would you like to observe? Meaning it was not just like engineer build something, go find a use for it. It was like, what do you want? What can you build? Let me act as a bridge. That's why she has such a high regard in NASA, where it's like, she actually is classified as mother of Hubble. Because if she did not have done that work, where they were like, okay, astronomers, what the hell you want? Engineers, what the hell you can build? Let me balance it out. Then we would not have Hubble. So that's why she is such a revered figure in NASA, and that's why it is the telescope is named after her honor, Roman. So that was amazing thing. And again, not to mention, she was also first woman to held a very high position in NASA. So amazing achievements. So this is Hubble's replacement. Literally, is same mirror also, as in like diameter wise. So what about the design of it? Design is exactly the same. Control C, Control V. The mirror diameter is 2.4 meter. However, this is one core aspect. The design of Hubble was taken from a spy satellite, but not the glass. Here, the glass was pre-ground, meaning everything about this glass is done. It's ready. It's like you can use it right now. So what changed here is that they grounded the glass, meaning you have to like shape it. Now, once you shape it to your specification. The specification was different. Hubble specification was a telescope, a zoom-in equipment. This was a spy satellite, meaning going in generally low Earth orbit, so it has to have a wide field of view. Otherwise, it like everything will be like whoosh, whoosh. So it has a ludicrously wide field of view. How wide? This puppy is Hubble. This huge daddy is this puppy. So that's the whole point. Hubble is tiny compared to, like, this is like comparing like 16 millimeter versus 200 millimeter. Like 200 is Hubble and 16 is this one. It's like huge, 100x difference is there. So it's mind-bogglingly, bonkers. So it was designed for wide ground operations. Of course, it has done that. Now, in what does it mean, like to have a large field of view? What does it mean? It simply means for Andromeda galaxy, Hubble took many photos over years in order to create a collage that was like, it has everything analyzed into it. Okay, awesome. How long this puppy will take? Few days, years to days, even with the same goddamn diameter. Now that should trigger some alert. It's like, okay, I get it, you have a wider field of view, then how can you have resolution? Like, we have telephoto lens, we have a wide angle. It's like saying you take a wide angle lens and you crop in as much as you want it and you will get the same resolution. Now again, thankfully in space we don't have dust and atmosphere, but you still have to worry about, like, other things. So how the heck we are getting that? That's simply because we have newer sensor technology that actually allows, in the same photon budget, basically Hubble photon budget and this photon budget is exactly the same. So how the heck you have this much oomph out of it? It's because of efficiency improvement in sensor technology. The sensor Hubble has is like barely anything. Your mobile, basically mobile phone sensor will bitch slap Hubble at this point in time. Flat out, not even a joke. Flat out, it's like, bro. And if like Google engineers went there, it's like, bro, Hubble, what the hell are you doing? You're blind, man. Let me show you. So that's what happened here. And mirror is supposed to be a bit better. Now why? Well, if you are familiar with Hubble, you know for a fact they grounded it wrong because of one measurement instrument was crooked. So they require a contact lens that was flown up there to patch up Hubble in order to get it working. Here they're not supposed to do that. So less optics equals bit better performance. So that's the design of it, meaning tiny telephoto lens to ultra wide lens. So why we are saying that we can do something like that? This is the reason. This is the tiny sensor that is used in Hubble. This is the big boy that we will be using it tomorrow. Now this puppy is 300 megapixels. And it is sensitive from visible to near infrared, a little bit of ultraviolet, but mainly visible to near infrared. And because they are now focusing, everything is now slowly focusing on further galaxies, so we are like going deeper and deeper into infrared. So ultraviolet is not that more important. I'm like flat out, it can barely detect ultraviolet again, but if it's strong enough, because it does not have too many filters, it can detect it. Now it has a filter wheel on top of it, which has 7 slots. Now those slots has one wideband, meaning it will let the sensor shine, just absorb as much photon as you want to do and just give us data. Then it has 6 narrowband filters, which will be specifically selected for the missions like hydrogen alpha filters and things of that nature. There will be filters. Now this is the reason why it is 100x more powerful than Hubble, even if the photon balance is same. A bit better because it does not have contact lens to correct it, but overall this sensor is the main reason, meaning how clean ISO, basically you are boosting the sensor size and ISO performance, not changing anything else. You are just boosting the ISO performance and sensor size. And it also has a basically grism and prism for slitless I can never say this word, spectroscopy. This should allow you to, this puppy to observe a lot of point star as long as it's not too crowded and understand its spectra very well, meaning what is the gas distribution, what is things are happening without any serious issue. Hubble also has Hubble, I'm saying James Webb Space Telescope also has that. It is really preferred to use that when you have a lot of stars but they are sparse out, meaning if you have 1 star here, 2 star here, 1 star, like if it's spread out, some bright star, then you will have that filter in front of it. It will spread out and hopefully it will not overlap, and then tada, you will have what you need to know of multiple things at the same time. Old ways you had to have a slit and that slit would correspond to a sensor, then you will get the data out. This is much better, much more faster. Then we have a new experimental instrument, that is Chronograph instrument. Now this instrument is inherently a sunshade, meaning it blocks the starlight. That's all it does. So why you need to block the starlight? You have to understand, when we are talking about planets, we are able to observe planets in multiple ways. First, you look at the star, you let the planet go through it, okay, and then it will dim it a little bit, and then you will figure it out, like if it is happening repetitively, meaning you are observing this thing for years and you're like, okay, every 2 years it dips, that's a repetitive system, then you're like, there must be something. How much is dipping? What is the brightness of the, calculating all that data, you can figure out something like that. That's used by Kepler. Then you can have a scenario where you have a star and orbit, like your orbital plane is like this, like you are looking top down. So then in those sort of scenario, you can have either this method, or you can figure out like what is the Doppler shift, or what is the quote-unquote wobble in the star, because the planet does cause wobble. It's very little, very faint, but it is detectable. But unfortunately, both of those methods works really well for gas giants, because those are huge. They do have that oomph where they can actually affect things. Now this puppy is specifically targeting rocky bodies. it does not mean those two methods cannot detect rocky bodies. It's just generally it will be too close to the star in order to create that sort of observable effect. This puppy should allow to observe rocky planets. Basically, if this puppy was million light years away, not million, like few 100,000 light years away from Earth, it should be able to spot Earth. That's the whole point of it. So it has masking, exactly, it has to have that. Then it has optics. Now critical difference here is rather than just having masking and be like done with it, it has this sort of complex mirror arrangement that should allow destructive interference for blocking, meaning it's going to take two wavefronts of the same star and make them cancel each other out. Basically, you can let the animation see. This is the disk system. They will have the mask, and again this mask is not just like block it. They will try to create interference pattern and then properly adjust it until it goes whoop, and voila. You will not have, like, basically the starlight will disappear inherently, and then you can see very faint objects around that star. This should allow, if you're the plane or basically orbit image sensor plane, and basically plane of the star aligns up properly, you should be able to observe multiple planets around it if they are orbiting their rocky bodies, not gas giants, rocky bodies. That's the whole point. Now, it is not the main mission simply because this technology is too new, too untested. This sort of destructive interference sun blocker, so to say. Now, if it does work, it will act as a proof of concept. Remember, we had sent a rover, Perseverance rovers. It had a helicopter in it. What happened? It was supposed to be like just a test system, but it worked so well, everybody's like, let's just keep continuing it. Same could happen here also. It was designed in such a way where it's like, for first 2 years, even if it works, they will not share the data with the public. Once they have to verify everything, double check, triple check everything, because again, destructive interference could create a scenario where you have a lot of false signals. You have to be damn sure like it's working before you send the data to public. So once they verify this sort of technology works, then only they will open it to for public. Then when we're gonna launch this puppy, it's supposed to be launched basically to exact same location as James Webb Space Telescope L2. It will go there, it will orbit the same thing. Now there is a consequence of that, same as JWST, no upgrades, no serviceability, even though it's a like inherently a design that can be serviced. But you have to understand, after the Hubble there is nothing to be serviceable in space. Why? There is no vehicle that can go. The best the planet has at this point in time is this Chinese Hubble clone basically, and it was designed in such a way that it will dock with their space station. Basically they have designed in such a way that both are in the same orbital plane, so they can dock and undock with each other, and then they can have people and crew with things of that nature to actually service it, upgrade it. Nothing else at this point in time is serviceable. So NASA is kind of like, we can't service it even if it was in low Earth orbit anyway, because we do not have any space shuttle at this one. Like Dragon can actually go to space, awesome, but it does not have robotic arm. It does not have enough oomph where it's like, can change its orbit, stay in the orbit for a very long duration. Again, it can be upgraded too, but right now it's not there. So they're like, might as well save cost and make it far more reliable. And again, at this point in time, we know how this works. So that's all right, because it will give them much better observational possibility, because it's a large area lens, meaning it's scanning such a large area. You do not want to be in a scenario where it's like moon is photobombing it or Earth is blocking it. That's why it has to be in that position where it has like clear view of sky. It's kind of like, I can focus it, create panorama without like it taking years, because many times Hubble also had this issue. It's like on the other side of the Earth where it's like, bro, I have to wait for Earth to like rotate or me to come out, and then it could have a scenario where it's like sun is there, tada. So for observational possibility, this was chosen that L2 is awesome. And it is planned for Falcon Heavy in May 2027. Now, this was the puppy that was donated. And again, this whole section is made by NASA engineers, and the glass section was like, donated. They stripped the whole satellite. Like, think of it this way, like NRO is like, yeah, we built the satellite, let's just lol it. They just yoinked it. So this will be the newest thing, and it has more oomph, more again, digital technology, better solar panels, and all this technology has been tested, so it should work flawlessly. Now, the consequence of James Webb Space Telescope was that it was so over budget. The cost of this project was toned down a lot. Otherwise, this could have been much further along. Like again, that's why I say like JWST has been classified as a telescope that ate astronomy. That's the reason. It's like many other instruments that could have like, I'm ready to go. It just never came to be simply because money ran out. So let's see what happens in May 2027. Hopefully it works, and it should work. Fundamentally speaking, there is nothing hululu going on into this, so it should work. So this was my presentation about Rome telescope. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.